Good afternoon and a very warm welcome to today's webinar hosted by the AI Academy here on behalf of Mile, Factimi, Pipe and Avail. We are super excited for today's webinar. The topic is language capabilities of large language models and specifically what this means for medical information and why this is so important to really kind of get upskilled with all of those technologies. So great to have so many participants in the call, and also very excited that we have actually two very distinguished experts specifically for AI translations from DeepL, from Google with us today. So we're having a couple of presentations, but then at the end of the session, also enough time for your questions to really make sure we all are aligned with what's possible with AI in those translation capabilities. But before we kick it off, just a couple of sentences about the AI Academy. As you know, the goal is really to empower MI professionals, right? We want to upskill MI professionals. That means kind of creating this collaborative learning experience, having those webinars to really make sure you get to know the latest technologies, and we really kind of drive together all of the industry insights to make sure we can drive MI forward as good as possible and have this hands-on education. So as said, on behalf of Mile, Factimi, Pipe and Avail, really happy to kick this off. And if you want to stay in touch and get informed for any kind of upcoming webinars, any upcoming events, please have a look here on the right side, scan the QR code, because they can directly register to always stay ahead and get informed when we have latest and newest webinars up and running for you. And with that, let me now super proud to introduce to you the speakers of today. So we have Paul Busch from DeepL, and we have Alexandra Jaworska from Google, both kind of experts in those AI capabilities when it comes to translations. And the goal for today is actually having 3 presentations from Paul, from Alexandra, and from me about AI translation topics. So the first one from Paul about scaling language AI, second one from Alexandra about what's next in translation AI, and then from myself about best practices for medical information. Before we kick it off with the presentations and the introductions, we wanted to get started with a quick kind of question to you, a quick poll, where we want to know kind of, just to get this started, what are the use cases of large language models you have in mind? Is it like translation, summarization, rephrasing? Like, what is it that at the moment really kind of drives your everyday tasks, let's say AI assisted? So before we get started the presentations, great to have a quick word cloud where you can share your results, like what language tasks are you actually working with? Right, I think we can already getting some response in. So please feel free, just drop any words which come to your mind when you think about AI, when you think about LLMs, kind of what are the elements you have here. Please let us know, and then we can just kick this off with a bit of an idea on what's on your mind. All right, already get some topics in here. That's great to see. But we'll have enough time also later to really deep dive on those topics. Okay, but we can then have a look later kind of on the result of this questionnaire, and then later in the open Q&A session kind of deep dive into your answers. But now let's get started, and I would like to hand it over to Paul to introduce yourself. Paul, great to have you here. If you could just quickly introduce yourself, and then we can kick it off. Paul, you're still on mute.
Sorry, I was just busy with the screen share. Thank you for having me on the seminar. My name is Paul. I work at DeepL. I'm research manager leading 2 teams working on foundation model training with LLMs. My own background is in physics. I've been working in different industries from computer vision to industrial automation and language modeling. And my current interest is mainly in LLM technology, also in voice specifically. And yeah, I brought a presentation about scaling language AI. I think I need someone to activate it, that it goes on the screen. Can you see the screen share?
Not yet. We're just bringing it up. Just 1 second, Paul.
Oh.
So just bring it up.
I mean, I can see it here that someone needs to activate it to bring it from the.
Just 1 second, Paul. We're just bringing up your presentation. As Laura, let's share it from.
Oh, you can see this guy.
Okay, I think we can now see it, Paul. I think
Thanks.
kick it off. Perfect.
Yeah. Then please skip to the next slide. I work at DeepL. DeepL is probably known by many here. It's a translation company offering translation in over 100 languages. One of the basically leaders in this field with 200,000 customers worldwide, where 50% of the Fortune 500 use DeepL. And I think this is probably well known. The company is also distributed internationally, originally from Cologne, but also with a strong presence in Berlin, in London, Tokyo, and in the US. What's maybe not so well known is that the company is also training neural networks since 2017, which means it's one of the AI companies from Germany, and basically has its own research to build foundation models. And that's basically the background where I'm coming from to talk today about scaling large language models. The next slide, please. Yeah. This is the interface that most of you will be familiar if you've ever used DeepL. It's there are 2 text boxes. On the left side, you have the source language. On the right side, you have the target. You can enter your text, and it will be translated to you. This is more or less the product that DeepL has since 2017. It's very popular. It's also a free app. You can just use it. Or of course, you can buy a license for it. However, there's a lot under the hood, and there's also a lot more to it, DeepL, than this, basically text-to-text translation. And this is where I want to get to today. And if you go to the next slide, maybe the first step beyond the text translation is that we have 2 basically 2 main products at DeepL today. One is the translator, which is what I've basically the better known product. And then there's also voice real-time translation, which does transcription translation and now also voice to voice. This is basically the way the DeepL products are structured, in a way, basically the large suite of translator products and then a dedicated voice product. And I will basically use examples from this product context from DeepL to talk about how LLMs are basically, we are scaling LLMs to power these products, and in which dimensions we need to scale them. So if you can please go forward. Exactly. So I'm going to talk about scaling language AI in the context of our DeepL products, but not limited to it. Basically, this applies to other companies, other research labs as well. But I will take, of course, a bit of a perspective that is informed by a translation product. Next slide, please. So LLMs, like large language models, are text prediction models. So what they do is you input some text and they predict the following text. And there's a couple of steps we can take from there. You start with text generation, but then translation is basically different task of text generation, where instead of just continuing the text, you basically complete the task of producing the input text on the output side. And then when we go further, basically in our scaling journey here, we take the LLM to also accept multimodal inputs, which means we either have it take visual input as context or speech. And from even a bit further, basically from the multimodal context of this translation, we're not just translating basically one text input or one element of text, but we actually build an entire workflow where the LLM is informed by more than just basically input text and more than just the reference media, and can complete an entire task. I put this here on the basically lower part of a scaling journey because I want to make the point that this is only beginning to scale, and there's so much more we can do with LLMs, and this is what I'm working on in my research teams. Next slide. There's a different view on this, and this is if you think of it as stacking on top of each other. So built on the backbone of the LLM technology, we start with generative AI, which has been like around for many years. And then on top of it, we built the multimodal capabilities of speech and visual context. Then the reasoning part where we can have longer context and we can do things like tool calls and actions. And then basically the highest level is we go to the frontier of how complex the task, how complex the problems can be, and how much utility we can get out of this model. And this is kind of a view where we're not like building this in sequence, but rather something that we are basically stacking to build AI technology or AI capabilities that are grounded on the LLM technology, but go far beyond it today. And if we go to the next slide, you will be familiar with many of these challenges. Like, although there's a lot of promise in this, we have some issues with LLMs around context, where we might have missing context, we have hallucinations, we have plausible answers that are wrong, and we also have errors where we don't even know what the confidence is for them. And then another issue with LLMs, of course, it's an expensive technology, both to run the models, but also to post-edit everything, like the high output of volume that the model can produce. And the naive solution to this, if you please go to the next slide, is to just scale the models, like to apply compute scaling. And with compute scaling, what we mean is basically we use more compute, we train larger models for longer. And this is something we do at DeepL. We've basically invested in more compute clusters. Here, the example is basically an upgrade of the training cluster we had over the last year. We are now like nearly 3 times as fast to train large models. But this is not the kind of scaling I want to talk about, because this is kind of like, yeah, a basic way to use compute for this, but we're also scaling in other directions. And the next slide, please. Largely in language AI, for us, those are 3 dimensions. So we're starting with LLMs, and the obvious scaling direction for us as a translation company is to scale multilinguality. That means we scale to more languages. The other is multimodality, which means we go away from text, we go to documents, we go to speech, we go to images. And the third dimension is to scale into the depth of a workflow. That means instead of just handling the narrow translation task, we're doing everything around it. We rephrase text, we post-edit it, we apply style gates and customization, and so on. Yeah, and next slide, please. In the dimension of multilinguality, we've basically done this in the last year, where we scaled from the classic 32 languages to over 100 languages, which means we've expanded the number of languages. But also, if you think about, like, you can translate any to any, basically there's a lot more combinations that we can have today. And next slide would be multimodality. Multimodality means that we can not just translate text, we can also translate images. And here's an example where from the left side, we have an English manual and we translate it to French. And probably the resolution is a bit low, but the point here is that the basic basically approach, or the approach without a vision language model, without a LLM that has vision capabilities, just misses a couple of points. So we get like a better a translation and also a better reconstruction of the document with the VLM. Next slide, please. And the other thing is multimodality on voice. So coming from, so DeepL voice has been around for a couple of years, but it used to be a speech-to-text translation product. That means you transcribe the text and you translate it and you show the translation as text. This actually like 2 months ago, I think we launched publicly the voice-to-voice translation, where you do this translation directly on the audio side. And you can still have the text translation, but you can also just listen to the translation in the target language. And the last step is the depth of workflows. That means instead of just using the app to translate one text element to the other side, you have a kind of interactive way where you can, for example, preview this document translation and then ask for requests. And you can also use our API to build on top of it to build DeepL into different parts of the basically of your workflow stack. And then the last thing, just a point for me to make is that when we talk about scaling LLMs or like scaling language AI, it's not just the model we're scaling, because the model basically is only the core of the AI solution. And around it, we have something we might call a harness, like the tools, the context, the memory, kind of like very close mechanisms around the model that basically give it additional capabilities. And then we have the application. So we have a workflows, we have a human interface, and then integrations that allow us, for example, to provide the model with more context. And all of this basically is scaling at once. So we're scaling the capabilities of the model itself while we're building a better harness and a better AI application. And there's just a lot of basically innovation happening right now. Right. Yeah, so much from my side. Sorry for the poor screen share, but yeah.
Perfect. Thank you so much, Paul. It was super interesting also seeing kind of how those, let's say, core foundation models are going to build out, how the scaling works, and how this kind of also the vision that DeepL is kind of moving from kind of the text-based up to kind of the workflows. Super interesting to see also kind of the voice mode. Those are really, really exciting things to see kind of here at the core layer. So thanks so much. Paul, I think we will have a lot of more questions later on in the Q&A. So we'll kind of then tackle all of them later. But for now, thanks a lot for your presentation. As a next and second speaker, now really excited to get Alexandra on screen, and happy to hand it over to you, Alexandra, for your introduction and then also your presentation. Please feel free.
Cool. Thank you so much for having me. Let me share my presentation and
Alexandra, are you still with us? Yeah, I think.
Can you still hear me? Because I just click share presentation and I was kick it off. That's strange. Let me try to share again.
Sure. Otherwise we can bring up the slides for you.
Yeah. Let me click again. If I will be kick it off again, then probably it means.
You know, Alexandra, let's do it directly like this. Let me share it directly for you and just let's walk through your slides. Perfect. Then if you could please start with your introduction. Thank you, Alexandra.
Okay, because I already shared my screen, I'm not sure.
No, we can see it now. Let's just kick it off.
You can hear. You can.
Yes.
Okay. Cool. Perfect. So great. So thank you so much for having me. My name is Alexandra, and I'm an AI engineer at Google, and I have the honor to speak to you today. So I'm going to focus deeply on one of the most persistent and critical challenges in global healthcare, which is mainly medical translation. And today I'm going to dive into the technical and kind of educational realities of translation today. I'm going to explore exactly what are the current model struggle, the architectural reasons behind those errors, and mainly how current LLMs can overcome all those hurdles. I'm going to also share kind of actual benchmark to understand where the automation is reliable and where the human review is still remain essential. Let me move to another slide. But before we dissect to the translation, I would like to mention about what has been established as a kind of architectural foundation that makes modern workflow possible. In 2026, so this year, the industry made something that's called agentic pivot, which actually moved from the kind of conversational models that merely answer questions to the kind of system of action. So for example, you can use LLM models like Gemini, like one from DeepL, to execute complex clinical workflows instead just typing questions and getting kind of fluffy answer. At the same time, I would like to introduce to you specialized open weight models, which is also kind of open source model, which the name is Gemma, which already hit the milestone scoring nearly 90% of one of the US medical benchmark. However, for us, for here in Europe, this particular LLM model also is compliant to European AI Act. So for us, it means that we can actually freely use it here in Europe as well. So let's look into the translation. Why actually it does matter so much. So because mainly the accurate translation is a kind of fundamental matter for patient safely. This is how I actually understand it. I was also, or I am patient too, so for me it's also important. So let's say when patients do not fully understand they discharge instruction due to whatever language barriers, or they see that kind of issue with it, we can see that people will really want to understand how to manually read, let's say, what they get from a kind of instruction or medical instruction. And what's important here that the current LLM models, like for example, wherever Gemini, DeepL models, can be really, I would say, can make a difference comparing to kind of old school legacy translation tools. And having that said, for example, by capturing like very complex, let's say, terminology or meanings from oncology, from cardiology, wherever, including regional dialects, we can mitigate the clinical risk and also, at some point, democratize the access to the global clinical trainings. So not only, I would say, patients will understand clearly what actually doctors would like to say, but also I would say we can work on deeply on a clinical researchers for build a kind of solution for clinical researchers who would like to invent something from that perspective. Let me move forward. To actually fully understand this technology, we must be very honest about where actually there are some kind of struggles. Mainly, medical translation is incredibly difficult. What does it mean? So first of all, we can consider, let's say, clinical abbreviations. So for example, a doctor will describe SOB in a chart, and a standard AI model might translate it literally as a kind of wherever phase, mainly it can hallucinate something rather than translate it as a short of breath, for example. The second is medical homonyms, for example, which actually telling, for example, telling a patient their tumor biopsy came back positive. So for clinical, it's a crisis. It's really important, and I would say information, and it needs to be politely shared with patient. But for a kind of basic translator, when you get like kind of positive. So for such kind of translator, it means that, okay, this is great results. Let's be happy, which is absolutely not the right path. That, for example, AI should share that kind of results with a kind of joyful, and happy comments. So we have these are kind of two examples, but we have several of similar hurdles, which can be, come from regional dialects or from, let's say, anything else that also change depend on the cultural or the whatever region they came from, and it's really important to handle it correctly. Before I will jump into the kind of solution, how the LLMs can, bring the value right now for medical experts, let me also mention why all those errors actually happened. So historically, AI translated sentence. So AI models, artificial intelligence models, usually translate sentence by sentence, because it had like a narrow context window. What does it mean? Mainly that literally the AI forgot what was said in a few paragraphs ago, losing the patient overarching narrative. Furthermore, usually LLMs also operate on a token probability. And from the mathematical perspective, it means that the models guess the most likely the next word. So for casual conversation, it works great, perfectly fine, because from the mathematical perspective, the next word is really easy to predict. However, in medicine, the correct word usually is very rare or highly specific outlier, so it's really hard to guess it without having a kind of a support knowledge base that will be added as a kind of additional knowledge into that particular LLM model that will work for us. So how we can fix it? So I already shared a little bit. As you can see on the architecture diagram on the screen, the solution for it is called RAG, which stands from Retrieval Augmented Generation. The idea here is that we will combine the LLM with massive context. So the context that is very specific for us, and it's important for us. And the model was not trained on this before, and will not be trained if we don't want it to do so. So how it's working? So instead of guessing word by word, the new LLM models like Gemini, like one from DeepL, already have like a multi-million token context window. So what does it mean practically? They can ingest entire, for example, 200 pages patient chart at once. It doesn't need to, split it into and chunk it into small piece of text. So, but what's even more important, if you look at the flow, before the AI output a translation, the AI usually query your internal knowledge catalog. So what actually is doing, it actually looking at the data that you already shared, that are very specific, your data, from wherever data they came from, our guidelines, or wherever medicine-related prescriptions, and so on and so forth. And we prompt the AI to reason about the clinical intent first. So it will not hallucinate. It will, check whether the answer that the model would like to share, it's accordingly to the knowledge catalog you are going to share with it. So it shifts at the end from the statistical guessing to the, I would say, the right reasoning, eliminating the kind of hallucination errors, because right now the model are very complex and sometimes it's not very clearly, it's not easy to, I would say, remove such kind of variable called temperature to 0, and it will remove hallucination. It's not working like that right now. The main topic here will be to add the knowledge to your AI models. Let me jump into the benchmarks right now, just to give you a kind of glimpse on how the past, I would say, neural machine translation models worked, and how are the current benchmarks for currently available models. So in past, it was like about 78% of clinical accuracy, because all those, I would say, the mapping errors I mentioned, or bad interpretation based on whatever semantic related things. And right now we have, when we add the RAG, so the augmented knowledge into the LLMs, we can push the accuracy into almost 95%. So it's a huge change. However, I would like to mention here as well that it will not replace the human. It will significantly, improve the work that the medical experts and the humans will do, but definitely will not replace it, because still we need humans who will answer questions more politely than even wherever AI models will be able to do so. Having done benchmarks in a head, let me show you the kind of diagram that presenting how in fact the human in the loop works, having in mind the entire system that will translate and help translate the complex I would say wordings that are usually used in healthcare. So for example, AI can be super helpful when it comes to check or work with routine tasks, and it can auto approve it based on whatever rules we are going to define earlier, and they will be defined, and is a kind of guidelines that will be applied to the system that will translate something, and we can safely leave it on a LLM models. But for example, for some very crucial or complex, let's say surgical context or novel therapies or whatever, mental health evaluation, we can still, let's say, automate some roads to the output to the human expert for review. So for a really critical part, we have still human in the loop who will answer the question or reject or accept what actually at the end LLM translate for us, and whether it's according the rules that we already used in the past, for example. So in fact, AI will handle like about 80-90% of the volume of the work, and will free our human expert to focus on the really deep oversight on the most sensitive tasks, which will be about, let's say, 15-10%, depend on the use case, to be honest. Let me just conclude what I actually said. So what I would like to leave with you is that translation is no longer, I would say, the kind of risky widget. So you will type something, would like to translate, and it will get you the output that's not necessarily what you expected, especially for a very sensitive data. But right now you can create really safe and secure governed part of a patient journey. So mainly you can, in fact, you can focus on your exact work and give to the AI the part of the work that's already well written, and I believe a lot of healthcare companies have some kind of, let's say, rules they followed. So it's quite easy to implement them and reuse the currently available LLM models to help translate what's important and help patients or researchers to work on what's let's say important. So actually bound physical and physician and patient together instead of fighting with strange translation tools, which actually was available in the past. So having said that, I would like to finish my presentation, and if there will be any questions related to what I said, happy to answer. Thank you.
Perfect. Thank you so much, Alexandra. That was a really nice presentation. I especially kind of liked at the end kind of this topic you mentioned there, kind of technology as a silent partner. I think is a brilliant concept of something which can be there, and then kind of the expert review there to really, let's say, empower experts to then kind of deep dive on specific topics. I'd like to now directly start with the last presentations of today before we then ultimately go into the Q&A section. Just super quickly, my name is Alexander Götz, CTO at Avail, the company behind the tool MedPro. We are, of course, also focusing, and we are focusing specifically on those workflows in medical information. And this is what my presentation is about, because it's really about best practices of using all of those technology layers which we have just heard about in medical information, and what elements to consider to be successful applying and using those new technologies. To kick it off, I'd like to start it with this slide, because what we have learned across the industry from our customers is that there are actually those two major use cases, those key use cases, which kind of define most of, let's say, the topics around translations in medical information. And the first part, on the left side, you can actually see here language agnostic content creation. So what does this mean? You all know kind of there's a lot of, let's say, sources out there, a lot of content out there. For example, there's an English study, but then there is a Spanish, let's say, regulatory document, and ultimately you're maybe a German native speaker. So there's a lot of different languages all around in the input, in your output, and the way how you think. And one important concept which AI enables is actually working across all of those different languages in a seamless way. That means we do not have to care about what the input language is. We do not have to care about what the output language is, or which language we work in, because it's all kind of seamlessly translated as soon as we go with the content creation. That's one of those use cases we see where people really kind of can benefit a lot from AI as a technology and enabler for their workflows. And the other part, that's of course the concept of localization. Because when, for example, any, let's say, global content is created and we then want to localize it for any local markets and local languages, this is one of those parts where AI with translation can help. But of course, localization is not just translation, right? So then there is a lot of more details to it of what it takes to make a successful localization. But AI with translation features can already help here a lot in this use case. So let's keep those two buckets in mind of the key use cases across MI. And let's now see what patterns, what, let's say, best practices can really help to drive those use cases with the technologies we just heard about. And that takes me to the next slide, because here we can actually see such a flow here specifically for how content here on the left side in the global MI teams, how global content can be created, for example, in English, and then kind of going through the localization flow. And for this localization flow in the MI teams, the first step, and this is where already kind of a lot of the effort can be taken with the technology, with AI, is actually doing the first draft with AI for the translation into the local language. And then after this first step, and that's the very essential part, the local MI experts can jump in and review those specific steps and make sure the qualities really live up to all of the regulatory and compliant requirements which we have. And this is what we here call kind of human in command, because AI kind of gives a first draft, but then the local MI expert is really here in charge to make sure all of the details are 100%. Because as we know, sometimes the first 90% are actually the easy 90%, but getting it to 100%. And then there's nothing else than 100%, right? In our industry, this is where kind of then the experts come in to do all of those checks and make sure it's ready then ultimately for the local fulfillment and deployment. So basically then making sure that this content kind of then also goes out to HCPs and to patients. But let's now really focus on what does it mean, this kind of quality assurance step in the middle, like where does the expert come in? How does it work and why is it so important? And this takes me to the next slide. And before I want to kind of deep dive on those specific checks, I want to mention one study which was published last year from Brewster. And what they actually did is they compared 3 different modes of translation of medical content. The first one is just using AI itself. The second one was basically an expert doing the translation by himself. And the third topic they here investigated was basically having an expert being empowered by AI. And the result of this study was that the expert being empowered by AI is comparable or better than basically the other 2 control groups here. And that means kind of we see that the combination of having, let's say, those AI models for a first draft or for any iteration, and then having the expert with all of the, let's say, specific knowledge really kind of can create those best results. But now, obviously, the question is, what are those checks we need to do to ensure those really good results? And there's a couple of different buckets I want to talk about. The first one is actually about technical terms, because technical terms is a matter of consistency, right? So you don't want to have at some point you want to call, let's say, something a syringe and then inject in a pen. No, you always want to make sure that you call this, let's say, specific in a specific content, you call it syringe, and always in all of your content. Same also goes with the brand names, right? This is also about consistency. Of course, you need to have for the right market, the right name. And this is not something where we want to rely on the statistical token probability, which Alexandra mentioned, right? It's not about that in 90% of the cases, it gives us syringe. No, we want to have it in 100% of the cases. And this is why those parts need to be checked precisely. The third bucket here you can see is regulatory and legal precision. And that's a very similar topic, because if there's any disclaimer, of course, you want to use it verbatim as it is. There's no need of translating certain sections, because some of those elements are strictly and should be strictly used as given and not being, let's say, drifted. Maybe the meaning is still the same, but we still want to use exactly the language which we have in our defined, let's say, disclaimers and any warnings or all of those texts, just to avoid legal risk. There's no need for those specific parts. But this is also something we need to take care about in those, for example, localization workflows. Another very important point, and this is more kind of about LLMs and the nature of them themselves, is that it is very important that the human expert also checks specifically rare or new terminology. So that means kind of if something, there's a new molecule, a new name or something which is not well known, or it's just internal knowledge, for example, especially then it's important that human experts come into play and really review those specific technical and also terminology terms to make sure we really follow those standards. That has also, of course, something to do with the fact that those large language models are mostly trained on public data. They have a certain training cutoff date. That means some languages which are new and only internal might be or need to be double checked. And then a couple of more topics. Translation of image content is also very important to double check, as here in this case, it might be very important where specific text is placed. We saw kind of specific image translation capabilities. Paul presented this, how DeepL can enable such workflows, but still here it's very important to see that then the text in those images is well placed and just understood in the context. And then third part is also terminology across documents, right? If you kind of consistently translate a lot of documents, of course, you want to make sure that in every of those documents you have the similar and same patterns to make sure you have a well-translated content. And all of this can be solved. I mean, this is where MedPro also kind of provide prompt libraries and certain glossaries to make sure we can really kind of assist also in those workflows. All right, so this is the hybrid approach. This is how ultimately kind of what you see here in the study on the left side, how this can be achieved. And specifically, those are the checks from MI perspective, which are necessary in order to achieve those 100%. All right. And just to sum it up, kind of how to now use large language models, how to use AI in medical information for translation in a responsible way. Just to quickly summarize it again, yes, it totally makes sense for the first 90% to use AI as a draft, but then of course having the human in command process to make sure we can really get to those 100%. And this is then by making sure we have the right terminology, we have the right disclaimers verbatim, right? We don't have any deviation here, and we validate any very specific terms and make sure we follow the local regulations. And this is then to be reviewed by human expert. All right. So this was my last slide, giving you a bit of an overview kind of in, let's say, how large language models and AI can be incorporated into translation workflows, as said, for kind of either language agnostic content creation or for localization workflows. And now we have ultimately time for a few more questions from our side and just the open Q&A session. So I quickly also hand it over to now finally also we want to put some polls out there now at the end before we kick it off in the Q&A session and see that we have a few more questions to also get a bit of feedback from the audience of specifics of your workflow. So the first poll which we have is, how are you translating medical content today? And so there are a couple of opportunities here. Like, we currently don't translate medical materials. Our team handles translation in-house. We use Gen AI tools like Copilot, DeepL, Gemini, and so on. Or we work with professional translation agencies, or we use specialized medical regulated translation solutions. So please do let us know kind of what are your workflows today for translating any medical content. As said, kind of all about MI, could be FAQs, could be some response documents. What are the elements? Yeah, let me quickly also see what we have here. Yeah, I can already see kind of the first responses coming in. We have actually 39% saying we already use Gen AI tools. So majority here, it's still growing, 44%. So it seems that the usage of Gen AI tools like DeepL, like Gemini is already well spread, but still also, and that's an important part, kind of 32% use translation agencies, so relying here on externals. And also a couple of more questions. All right. Perfect. Then let's quickly now do a second round of polling here. Second question to the audience would be like, how confident are you in using AI for medical translation today? So you just said, or we just heard and saw that kind of there are tools out there. We do use agencies, but I'm very curious to hear from the audience kind of what is your confidence level in using AI today? Like, how much do you really kind of ultimately trust this? And I can see already results coming up. Actually, the majority here goes for neutral. So 30% somewhat confident, 30%, only 10% very confident, and 20% actually concerned about accuracy and compliance, and 6% we do not use AI for translation at all. So we see kind of we are rather on the somewhat confident neutral side, still evaluating, which is totally understandable because exactly of all of those topics we had, which kind of by AI itself might not be solved 100%. All right. And now the third and last poll we do, which is about, and this is kind of, you can rank it here on the poll. what is the main value you actually expect from the medical translation solutions? Is it just faster turnaround times, so really just time gains? Is it quality, so improved accuracy and consistency, or regulatory compliance support, or lower translation costs, or in the end, better patient customer accessibility or scalability across markets? So different topics here: time gain, quality gain, compliance gain, markets, patients. So please do let us know kind of how you would rank it here in this last of our polls. And I can already see kind of responses coming in. And actually on the top, I can see already that faster turnaround times is actually currently leading. So we have on the top one, faster turnaround times. Then we have improved accuracy, consistency, then regulatory compliance support, then lower translation costs, then better patient customer accessibility, and on the very bottom, scalability across markets. So we can really see kind of faster turnaround times and accuracy, time and quality are actually the main value drivers which you see here across all of those, let's say, new technologies, how this could enable you. All right, thanks a lot for your answers. I hope it's also interesting for you to see how the industry thinks about those topics, what really drives this forward. And now we can actually jump into our Q&A session. Okay, perfect. So bringing Alexandra and Paul on screen, and I can already see the first question coming in. Thanks a lot for your question. It says, we receive global documents in our language, therefore we want to use AI to focus more on the localization. Local license nuances, is this something LLMs are good at? So that's the first question, kind of using AI to translate those global response documents. And I think this is really kind of what we kind of talked about is because yes, you can definitely use AI for kind of the first AI draft. But then again, those local license nuances is then exactly kind of where the human expert comes in. MedPro, for example, can help you setting up a couple of those things in prompt libraries, for example, to make sure you can follow also those local licenses, like license nuances. But that's exactly one of the cases where kind of after the first translation, you would then, assisted by specialized tools, also can make sure that those local nuances are followed. But as said, this is then something which is not a, let's say, general translation service, but a very focused and specialized one. Thank you for your question, Portia. Okay. Any other questions from the audience? Also for our experts from Google and DeepL, as they are really focusing on the core technology of large language models and the translation services, please feel free. Now is your chance to shoot some questions or any other topics about kind of AI. Happy to discuss all of those. There's a good question here coming in. What benchmarking models or tools are recommended to measure translation correctness and accuracy? Alexandra, I think you had on your slide actually a benchmark where you compared the human expert to the AI models. If you want to comment quickly kind of on those benchmarking your models internally.
Yeah, sure. Actually, I cannot share how we are measuring it, but there's, I would say, one very well-known, or not necessarily well-known, but still it's based on mathematical theories. It's hill climbing. Mainly, how it's working. The idea behind it is that we are, comparing the results of how LLM used to work. Used to answer, and we are comparing it to exact answer we are expected from the models. So mainly we are, in a very, I would say, to simplify everything, we are comparing how well the model used exact words we put as a kind of, benchmark for the model. So this is, I would say, the one way how you can compare whether the model, answering correctly and precisely. However, there can be, various, I would say, different options how you can compare it. So for example, when you prefer, for example, to use open source models, there are also plenty of them, and you can reuse it if you don't want to use, for example, the publicly available on cloud, for example, models like Gemini. So you can use LLMs that are available freely for you. So for that case, you can also, let's say, do something, I would say, more simple. So you can, let's say, build the kind of scenarios where, let's say, you have your questions and your answers in a, I would say, short form, let's say short answer, and you are comparing. You can use AI for it. Compare the AI model you are testing, and see what are the answers. And you can, for example, use either the expert, or you can use a different LLM model to compare whether the answer you get from the model are exactly what you are expecting. So this is like kind of a simple version of hill climbing, I would say.
Thank you, Alexander. Yeah, totally makes sense. I think that's also kind of a concept, always having those standard evaluation sets to check for the accuracy, and that's also what kind of at MedPro happens, that you have really those prompt libraries where you can like literally say this is always the term we want to use, for example, for certain, let's say, SRDs or any translations, and then they can be followed, and those are then the things which need to be 100% in order to have those accuracies really high. Okay, maybe also just a general question also to the audience, like of course, this is a very fast evolving field. So also if you have any, let's say, questions about the future, let's say, or what your thoughts are, kind of how this will also evolve in the next years. I mean, this is a very new field, just coming up a couple of years ago. But please also, if you want to share your thoughts on how you think kind of this will be in the future, like maybe everything directly voice to voice, no text anymore. So if you're happy to share your thoughts, basically how you think this might evolve, please, of course, feel free to do so. I also see another message here in the chat about what if mistakes are made in translation as opposed to staying in one or two languages. So I guess the question is more about kind of what kind of mistakes are made in translation compared to one or two languages. Maybe Paul, if you quickly want to comment on this topic, kind of what are the typical, or kind of at DeepL, what do you see kind of, especially when switching the languages?
Yeah, so maybe the first thing is to acknowledge that, of course, translation can make mistakes. It can also lose some context, or like introduce some ambiguity, because it's not just that there's not like a single right translation. Sometimes you basically, if you were to translate back and forth, you will lose some, basically maybe some nuance. And I think so the important part in this question, like should you work in one language or should you work like translate directly, is that I think in most cases you have one source of truth, you have one language of like a kind of a master document set where you know basically it's a reference, and then you need a very good translation tool to basically translate it directly to a target. And I think this gets a bit more interesting when you have multiple contributors contributing in their own native language, and then you need to merge it. But I think then it still makes sense to have like one language where you're reviewing this for consistency, and then translate it from there into all the target languages. But I think this is very much a workflow question. You don't want to translate unnecessarily back and forth. I think that's maybe a good rule. Yeah.
Makes sense. Okay, thank you, Paul. Thank you, Alexander. I think we're already coming to the end of our session. We just have 1 minute left. And I quickly also want to share one slide to wrap it up, which is actually our reference guide, which kind of includes a lot of those topics on how to ultimately implement AI in your processes. So it kind of gives a good overview on kind of how AI can be actually put into place. So if you want to get your hands on the reference guide, please scan the QR code here. This is kind of a general guideline on implementing AI and best practices around also translation topics, and specifically when it's about languages and AI translations, we also of course have an SOP directly on our recommendations. So happy also to follow up with that, also available on our platforms. All right. Then, as said in the beginning, we are super happy to also welcome you the next time at our webinars. So please stay in touch, subscribe to our channels, and then we also make sure you are invited to the next webinars. And with that said, Alexandra and Paul, thank you so much for having joined the session today. It was really interesting seeing those, let's say, first-hand experiences from the labs. So thank you so much for having joined our webinar today.
Thank you.